So a ratio is where we compare two different quantities, usually with different units, but sometimes we can just deal with the numbers. But usually just two different units. A ratio uses division to compare two quantities. You can write the ratio of two quantities, A and B, where B is not 0, in three ways. You can write it with words, A to B. You can write it with a colon, A colon B. That's kind of a stinky way if you ask me. But you have to know what a colon is to get that joke. You can also write it as a fraction, A over B. If you have a colonectomy, do you end up with a semicolon?
No.
Just wondering. All right. Now, whenever possible, you should always simplify your ratios. Reduce it down to the smallest terms. So let's look at example 1. A volleyball team plays 14 home matches and 10 away matches. We want to first write the ratio of home matches to away matches. How would we write that? Home matches to away matches. Yes. We would write first 14 to 10. Then we need to simplify that. What does that fraction simplify to? 7 over 5. And you should never, ever, 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 ever write a ratio as a mixed number. Ever. Don't ever switch this to 1 2/5. Okay? Then you're not comparing two numbers. You're just writing a mixed number, and nobody cares about that. So there's the ratio of home matches to away matches. How about the ratio of home matches to all matches? Home matches to all matches. What do you think, Sarah? 14 to 24, because they played a total of 24 matches. You just add the home matches to the away matches. What do we get when we reduce that ratio? David? 7 over 12. There's our final ratio. Everybody follow so far? So these are ratios. A proportion is a statement that equates two different ratios. It's when you have one ratio equal to another ratio. And so we're going to solve one such proportion. So suppose we have 11 over 6 equals x over 30. We want to know what value of x would make these two ratios equal. So I have x divided by 30. How do I get rid of a divided by 30? I multiply both sides by 30. That will cancel out the 30 on the right-hand side. What will I have on the left-hand side? Emily. So if you multiply, yes, we could have 330 on top, but remember at the bottom is just 6 times 1. Okay, you don't multiply top and bottom by 30, just the top by 30. What do we get when we divide? How many times is 6 going to 330? Yes, 55. Now we could have shortcutted this way back here. Done some simplification. We have a 30 on top that will reduce with the 6 on the bottom. What goes into both 30 and 6? What goes into both 30 and 6? 6. 6 goes into 6 once, and 6 goes into 30 5 times. And so we'd have 5 times 11, which is 55, over 1 times 1, which is 1, which is just 55. Now, the easiest way to check this, we want to make sure that 11 over 6 would equal 55 over 30. Now, first of all, we can reduce the 55 and the 30, right? What goes into both 55 and 30? How many times does 5 go into 55? 11. How many times does 5 go into 30? 6. Okay, so we have 11 over 6 on both sides. The other way you could do it is in your calculator, do 11 divided by 6, and then do 55 divided by 30, and you should get the same thing both times. Okay. So when we're setting up proportions of different quantities, we want to make sure that the same values show up in the same places. So, for instance, if we had a recipe for tomato salsa that calls for 30 tomatoes and makes 12 pints of salsa, and we want to know how many tomatoes, so let's say X tomatoes, how many tomatoes do we need to make 4 pints of salsa? We have two options for setting up our proportion. We could do 30 tomatoes to 12 pints, okay? 30 tomatoes to 12 pints. And then on the other side of our proportion, we need to have the number of tomatoes to the number of pints. So notice we match across the top, we match across the bottom. Okay. Our other option is to say I could do with 30 tomatoes over X tomatoes. I could compare the number of tomatoes and the number of pints, but I have to be careful when I do this that I put the number of tomatoes on top and the number of pints on top that come from the same recipe. So since 30 tomatoes makes 12 pints, if I have 30 tomatoes on top, I got to have 12 pints on top. And then we're looking for X tomatoes to make 14 pints. So you got to make sure you set up the right order. Let's look at example 3. It says the elevator that takes passengers from the lobby of the John Hancock Center in Chicago to the observation level travels 150 feet in 5 seconds. I'm going to write that. 150 feet in 5 seconds. The observation level is located on the 94th floor at 1,029 feet above the ground. 94th floor, 1,029 feet above the ground. Find the time it takes. We don't know how many seconds. Find the time it takes the elevator to travel from the lobby to the observation level. Now, does it matter that the observation level is on the 94th floor? No, because they didn't tell us how many floors it travels in what amount of time. They just told us how many feet. So we're going to use how many feet to find how much time. So in our proportion, what do we want to put on top on the left? Yeah. 150. I asked what we want to put on the top, Ryan. 150 feet is fine. Somebody else, what do we want to put on the bottom? 5 seconds. Okay, so on the right-hand side, what needs to go on top? What needs to go on top on the right if we've got 150 feet on top on the left? David? 1,029. We've got a number of feet on top on the left. We've got to have the number of feet on top on the right. So what's left to go on the bottom, Lauren? X. We're going to want to find how many seconds. Now this is a little tricky. Uh-oh, we got an X in the bottom. We don't quite know what to do with that yet. You know what we could do instead? Watch this. What if I said I can travel, in 5 seconds, I can travel 150 feet? Is that still true? So in X seconds, I can travel 1,029 feet. Is that all right with you guys? Make sense? I'm going to flip my fractions upside down as long as I flip both of them upside down so that I still have the seconds on top together and the feet on bottom together. So now how do I solve this? How do I get the X by itself? By what? not the 5. Yes. Right. X is being divided by 1029. That's what I want to get rid of. So I'm going to multiply both sides by the 1029. So think about what you need to get away from the X and how you do that. Okay. Now, I don't think we can reduce the 1029 and the 150. Well, we can by a factor of 3 if you really want to. 3 goes into 1029 343 times. I don't think it's really going to get us much, though. So if we multiply across the top, what's 1029 times 5? 5,000. Let's say this properly. We should have learned this the last couple of years. 5,145. When is the only time we say and in a number? For a decimal or a mixed number. Okay. So it'd be 5,145. What's on the bottom? 150. What do we get when we divide those? Go ahead and use your calculator to get a decimal answer. 34.3 seconds to get to the observation deck of the John Hancock Center in Chicago. Just a little interesting fact for you in case you ever go visiting Chicago and go to the John Hancock Center with some friends. Hey, let's go to the observation deck. It'll only take us 34.3 seconds. You'll know that, and you'll impress your friends if you have any. Any questions? All right, that's all for today.